Okay. Well, I was just shopping around for data sets, and then I have a friend who's from Ankara, Turkey, and there were elections in there recently, and then there's always some irregularities with elections in these places. With this one, after the elections and the data becomes public, so public data means so for each district, how did people vote? So you have a school district, how did they vote over there for all over the city? And so that's nothing, that's just public, that's available for public, so that just becomes public. And some people took it up and started looking at it closely, doing some analysis, and they were able to come up with things that would point it, not proof of irregularities by the government, but something that points in that direction. In this case, I will also go over a little bit over the knitter. First, I started using knitter. I was just looking around for something to present. I was never good at making slides, and so I just wanted to do something like this. So I first started using it casually, and then Vivian was saying, well, that's actually supposed to be a little bit difficult. So I was like, well, what does that mean? So while I was not using it correctly, I was using it, but I was not using like all the features of it. So then I went back and I started looking at like what I can actually do with it. This is a run of, I should have stopped this one. This is just an example of getting the longitude and the latitude of the centers in Ankara. This is a sample of only 50 data sets. So it took, I recorded it took 43 minutes to get 2,000 and close to 2,500. The limit on getting, you can get the, I don't know how Lila did it, but if you want to get the longitude and latitudes, you can get it directly from R. So I have a code in there, so you just plug in everything, you run it, and then it gives it to you right away.
What package did you use?
Okay, so let's take a look. So why knitter is so nice. So right now that I have some works in here, let's say it's like one, so like just one piece of data set, and then I want to know where to go. So Lila asks a question, and then you can open up the chunks, and then you name the chunks. So every code, so you can focus on, you can do the graphs in one code, or some other graphs in another code, like cleaning another code. So in this case, there would be something to do with the geodesics. Okay, so that takes me directly to where I want to be. So that would be the geodesics. And I can give you the code, but it's a little bit, it takes a little bit of time. And then basically, so this, where is it? This one gives me, so it's just geocode of the address. You want to take the address. From the data set, you have the school number, and then you have the district name, and then the city. So you parse those three things together, and then you just run that through the geocode. The only thing you need to make sure is that you want to make that unique. So for example, I had 12,000 data set, rows, entries. But out of those, some of them were just like boxes within the same school. And when my friend translated Turkish into English, he forgot to translate some of the rows. So I was just guessing, so I didn't know. So it stops at 2,000. For me, it stopped at 2,400 because out of the 12,000, those were the unique data points. So it's, there is one thing, there is a limit. The limit is 2,500 per day, I think. So yeah, so if you want to do something else, I guess you have to go somewhere else. And but let's go over from the top. So some of the things that you can do on knitter is you can make some global options. So right now you just call it global options, and these are libraries that you want to use, or how big do you want the figures to be, where do you want to put them after you run them, where do you want to save them. So those are global options. Everything below that will be run unless you change the chunk code. So if you go to another code, if you change it, then that takes over. Okay, so let's take a look at first. Let me make it full screen. Okay, so this was just a regular picture. So what you expect from after elections, demonstrators about irregularities. And then it was interesting, but then as I was looking for data sets on this, so I started Googling things around. And if you look up on the Google image, what you, so another thing that's nice about this is that you can add text and then you can add, so there'll be a website. So the website is already in it. The website is in the R code, but now you can just click on it. So those are kind of things. So if I click on this, it goes to whatever website it's supposed to be. And you see that a lot of plots in here. So people become very interested in it. There was a professor in Sweden who did some very nice analysis in this, and I emailed him for some more data, but he never got back at me. Okay, so briefly to go over it, some translation, and of course after the translation, you go and do some more replacing, renaming. There's different ways of doing renaming. I think for me this is what worked, and I have. So this is the form that I would want to, for example, publish. And if I look at my own code, I have other things in here. So to remind me, if I go back at this chunk, it's like, okay, if I want to rename a column, it's like this is a way of doing it. But then there's, or like if I want to replace something. So this is a replacement of, or like the translation. If you know the column name, then this is the most efficient way of doing it. If you don't know the, so you don't know what column number it is, and so it just replaces everything. Okay, so let's now let's see if we can take a look at just some very simple plots as to just to get an idea of which party is ahead from the two. And so sometimes a bar plot actually gives you all the information you need. And so in this case, I can go better on my code. Bar plots. So I can go on my code and I can run. I think this is the code. So you can hide the code on your presentation if you want. If you have some ugly code, something that you're embarrassed to show that someone else can do in like 2 seconds, I hide that. I keep it for myself, and then I send something else. So like this would be like an ugly code that I think someone else has a better way of doing it, but until then, I will keep it to myself. So again, just a simple bar plot in here. And the other thing you can do with this is that, so if you want to demonstrate, if you don't want to run the entire file, you can go to the chunk and you can run that chunk. So instead of highlighting.
Sorry, what did the bars represent?
Which one?
The bars.
Oh yeah, let me zoom in on that. I will go over that. Okay, this is just the total number of votes. These are the two main parties, the current government, and then this would be the main opposition. Quite close, you can see that the government's party is ahead by a slightly, has an edge. This is the third party. And the interesting part would be how can these disputed votes tip off the elections? And by disputed votes, what they mean is that, so what happened is, okay, so first from here we get an idea of what's, so you have the total votes, the two main parties, and there's nothing else. to it.
The first bar is the total vote?
Yeah, total votes. So if you add all the bars, should be. So there's nothing to it, just a simple plot to see. It gives you a very quick idea of what's going on. As far as demonstration, this is just for fun again. You can do just switch it very easily. You can change the coordinates. And that also doesn't give us any more insight than the bar plot. So the bar plot is already good enough. So there's nothing, at least for that. So there's nothing else to do in there. This is not the final. There's a way of cleaning up this. So you should be able to. So when you have a plot like this, you should be able to clean up some of the mess. It doesn't look too nice. But I wasn't too interested in this plot. I think this one gives a little bit better idea if I get rid of the total votes. So now you just have the 2 votes. Anyways, still, it doesn't give you too much details. Now, the more interesting part is the scatter plot. So let's run this chunk. Okay, so it's just a scatter plot, but as far as what it tells us, let me see if I can, because I need to be able to. Okay, these are the 2 main parties, and then you take the difference of the votes between the 2 parties per district. So you do that per ballot or per district. So you just take the difference between those 2 votes. This is the turnout rate. What is the turnout rate? Usually in the US, it's something in like less than 50%, maybe 60% it might go, but usually less than 6. In other places, it's a little bit higher. The interesting part comes here. So the turnout rate in some places passes the 100%. So there's something, so there's places you see that that's happening. So okay, so it's happening, somebody's stuffing the ballots. Now, it's still, like, what does it say about, either party could be stuffing them. So it could be the government, it could be, usually the government has more power, it's a little bit more in control to stuff the ballots. So now this is the interesting photos. Now, you do a fit. The fit tells you that when the turnout rate is below 1, the opposition party has the majority of the votes. So up to this point, you have the opposition party that is holding the majority of the votes. Now, as it gets closer and closer to 1, this is still a high percentage. I mean, this is 75%. This is going towards 90%. So that's still a high percentage. And then when you pass the 100%, you see that in those ballots, in those places, in those districts, the government has the advantage over the main opposition. Yeah.
How do we see that? Where do we see that the left side is more the opposition, the right side is more government? How does?
Oh, okay. All right, let me go to that. So AKP is the, I didn't translate it here because it looked ugly. AKP is the party that is in the government's party, and the CHP is the opposition. So now let's say you have, in one district, the AKP could have 200 votes, and then the CHP has 300 votes. You take the difference between those two, it's minus 100. So anything in the negative numbers, it means that the opposition has the advantage.
Oh, okay. So that axis is 0, right?
This is when they're even. Yes. Yes.
Okay,
so this is very
below
key.
that is the opposition.
Yes.
And as you go
Yep.
to that side, they.
So right around. So this is the 0, and then right around here,
right
when it
around
hits something like 90%.
90%.
And then when it hits 100%, it's all the opposition. So this is a beautiful graph, actually. This has become very, very famous. It has been published many, many times. So this is actually, if you do the, yep.
So, what do you mean by like over 100%? Like, is from that
If you have now just the how many people are registered to vote in a district. So if you have 100 people registered and then 120 people showed up to vote, that's showed up to vote in the box.
So
You open the box.
Turnout rate is the number of people per district registered. Number of registered.
The turnout rate per district.
Per district.
Yes.
How many people showed up, right?
How many people? Turnout rate is ratio over the turnout, basically. So out of the registered.
How many showed up over how many registered?
Yes.
How many registered per district?
Yeah. So
So
when you.
it's over one, that means.
So that means that there's like some stuffing going on in there. So it's still, it points in the right direction. It's, I think for these places, you need to do some more. So basically you need to go back and then you need to open up the boxes and then see what else you can get from that. I was not able, there's some more data points, but I was not able to get them. There's a few, some of them are government agencies, some of them are independent. They are, they're not available to public, so I can't get them. I don't know if someone can scrape them for me, or so. But let's go. So that's what we can tell from this one. There's other things we can tell from this one where I wanted to go into geoplotting. So if you were to make some plots geographically, and then you want to see. Basically, you want to focus on this, and if you want to take it to another level, would be in those districts where they're leaning. How do those people usually vote? Are they AKP or are they CHP? Which one do they normally prefer? And so that's the second hand of data that shows that this line is actually, it's happening mostly in the districts where the opposition holds control. So it's actually to actually take over, to actually win by a big majority in those districts, it's even harder. So that's some more stuffing in there.
What's the blue line?
This is one of the statistics is not my biggest, but this is so this is the smooth line. This is how you fit the line, and the linear method is the one you usually do. And then if you want to do a different fit, which will go through more points. So if I take this one out, then you will just get a more of a best fit line. So this is this is what I had first, and then, but this is too straight. I think there should be something better to actually be able to go through these points. So this one shows even more. It's even more. It's tilting even more up. So I think I would. That's even better. It actually goes through more points. Okay, and the next one is just a simple. So this is the same thing, but now you're just focusing on. Okay, so now you're focusing more on the section that you're interested, and then you see it even more. So it basically just to re-emphasize what you already had. Okay, so now that's the other interesting part, is that can you plot this per district and then get an idea of how those districts are voting and so on. That was actually I don't have very good plots on that. I have some plots. So this is the some more cleaning, getting the formatting right. This is the one that I also hide because this is very, very ugly. And these are the two libraries that I would need to get the data points. And now some more code. You can have the code later if you want. I will not go through the details of the codes. And yeah, some more ugly codes. And this was just because I don't want to, because we want to demonstrate in here what we have. And I do not want to run that code because it takes 43 minutes to get all of those data points. So this was just a sample to see. So this is for 50 data points. The nice thing is that you do it right there. You can do it on RStudio. So you don't have to, I don't know how you usually do it, but this is what I came up with to get your longitudes and latitudes. I don't know, this one worked for me. So this is 50 data points. I think you can time it and you can see what this one takes and then project it into 2,400 data points.
So when you say you used RStudio, do you mean you gave the city name and got back the last
Oh, I can show you. Oh, this is the, okay, so this is the, let me see if I can go to the data first. Let me show you the data and then, okay, so is this the data I used? No, I cleaned up the data already. Let me see if I can go here. Okay, this is what you use. This is the like small cities, towns, I don't know what you call them. And this would be the district number, more like a, I don't think it's a zip code. So this is all you need actually. You combine the district with, I don't know if it's a zip code, or like I think it's a school, this one is from the school, like all of the schools that have a number. So I think that's what this one is. And so that's what you do. And then you combine those two. So right here, this is the code actually. It's not bad, it's very simple. You want to make it unique so that you can save some time. And yeah. So you just have, this is the name of the data. This is the two things that you need. So you paste the address. In this case, I added the name of the city. And that's all that you needed to get. I was very pleased with it. I was looking around on how to get, there's websites. If you have very large data frame, you actually have to pay for them. So if you have something over 50,000, and there was one mistake I made. So while playing around with this, I went into some other website. I wanted to clean some more data. And then, but I forgot to replace the name where I saved them. So I saved the longitude and the latitude in the same place. So that took over. So then I had to do it over again. So make sure that if you're playing around with this, just change the name of your directory. Okay, so that was so far. The next section is deducer. Anybody uses deducer here? No? Okay, so have you used deducer? No? It's a graphical user interface. And let me see. Okay, so that is the code of the longitude and latitude. Deducer, this is just a summary that I took from their website. Basically, it's a graphical user interface that if you don't use R every day on your regular basis, so there's people who use it every day, they're very familiar with the code, then they should not use this. But if you use maybe like on Fridays or like a Monday or like once a month, you need to do some plotting. You need to do some simple calculations. If it's like every once in a while, so if you're a researcher, I was showing this to some of my colleagues at Hunter College, and they use MATLAB. The problem with MATLAB is that one, you have to pay, and then the other thing is it's not as friendly. You don't save, this one saves the code also. So it's a graphical user interface. You can also save the code so that you can reproduce your work. So basically, I would, if you don't use R on your regular basis, I would definitely check this one out. So I made some beautiful plots on this one, and that's where those plots came from. Okay, so these are just like some packages you would need to download, and this would be plots that I got from there, but let me see if I can do some demonstrations on deducer. I think I should have it somewhere in here.
Guys, I want to
to do a quick survey. We still have 2 group projects, right? Right? And 2 people to present. Do you think we should do the rest the other day, or we should finish it?
Go with individual
Yeah,
projects.
I'll be quick, but I get busy.
Okay, I can wrap it up. So basically, the idea is that if you want to make some interactive plots, so this is the plot that I had before, and then if you want to compare it with something else, you can compare it with like the districts. You can point at something out, and then it'll show like some other properties in another data frame.
It's interactive,
So
guys.
this was, well, I was looking at the plot that Vivian had on her website, and I couldn't figure out how to do that. So I spent maybe 30 hours to find something out. But I think this is beautiful. I really like it. I can, like, if you want to do some plots in here, very, very easy. So this is the console that you have. On the console, you have all of these. This is the spatial package. This is my favorite one. You can do some spatial, so you can build some plots. So you pull it up, you see OpenStreetMap right away. And then you have your options as to, well, I have to go. This is where I'm going. These are some plots that I already did. So these are your options as to what you want to do. Let me delete one of them.
Thank you.
So you can zoom in, you can zoom out, and then it's also quite interactive. So you can plot something, you see what happens, and then you take it out. So it's like some simple plotting, very easy to see. For me to show, to make the connection between the Scatterplot and this one, I would need to sit down on you one-on-one, but you can make also, you can see that connection. I spent a few hours on like trying to figure out as to how to connect those 2 plots. So you can look at the regions, and then the other thing I also was talking to my friend who's from there, so he can, to give me an idea of what these districts are, how do they usually vote, are they for this party usually or this party. So this is the spatial plot builder. You can do, this is the code, so it saves the code in there, so you don't have to, most of them don't save the code. So this is something that you can do. It saves the code, and then tomorrow if you want to run it again, you don't have to pull down all of these menus from the top and try to figure out what you had. I highly recommend it, again, if you are using, or like you can go back and forth. This also helps you. So if you're plotting something, you can look at the code. This is on top of ggplot. So the code in here is based on ggplot. All of the plots in here are based on ggplot. So you can look at the code in here if you're able to do some amazing things in here, and then if you want to go in RStudio and do that again in RStudio, you can go there and maybe tweak it up a little bit more. You don't have as much freedom as when you're usually programming, so if you're a hardcore programmer, you probably wouldn't like it. Yeah, I don't know if you have any questions. Yeah, I will leave it at that. The rest of it is, okay.